Standard 7.1, identify an arithmetic or geometric sequence and find the nth term, specific term, number of terms, and common difference or ratio. On my website for this particular unit, you will find two videos for Standard 7.1. 7.1 is on sequences, where we're finding a particular term or a term number, etc., in a sequence. The two parts would be part 1 for arithmetic, which is what you're viewing right now, and then a second part for geometric. And then Standard 7.2 is for finding sums. And so you'll find two videos for Standard 7.2 as well, one for arithmetic sums and one for geometric sums. So in this particular video, we're looking at sequences, specifically arithmetic sequences. And our first example says, write the first 5 terms of the sequence, explain why it's arithmetic, and identify the common difference. Alright, so we want to find the first 5 terms. And let's start with term number 1. When we're finding our first term, the n value for that term is 1. N is kind of like our counter, our quantifier. It tells us how many of something that we have. So here we have our first term. It's not an actual term in our sequence. So here we have, let's say 1, 2, 3, 4, 5. It's not an actual term in our sequence, but it's counting which term number we are on. So to find our first term, n equals 1, we're going to plug 1 in for n. So we have our formula t sub n equals 5n minus 1. T sub 1 equals 5 times 1 minus 1. And that works out to 4. So our first term is 4. We call that t for term, sub 1 to indicate our first term. Now we'll find our second term, term number 2. And to find our second term, we're going to do the same thing. We're going to let n equal 2. So it's t sub 2 is 5 times 2 minus 1, which works out to 9. That's our second term. For term number 3, we're going to repeat. N equals 3. Oops, n equals 3. So t sub 3 is 5 times 3 minus 1, which is 14. Term number 4, we're going to plug 4 in for n. Our fourth term is 5 times 4 minus 1, and that's 19. So T3, T4. And then finally, for our fifth term, we're going to repeat the process and get 24. Now, we want to explain why it's arithmetic. An arithmetic sequence is a sequence in which you are adding a common difference, is what we call it, to get from one term to the next. So is there a common number, a constant, that we are adding to get from one term to the next? Well, to get from 4 to 9, we are adding 5, and that's the same number we're adding to get to each subsequent term. And so that's why it's arithmetic, because we are adding 5. And the common difference, which we identify by the lowercase letter d, is 5. Now to find the common difference, you can always take a term and subtract the term in front of it. So to find d here, you could always take 9 minus 4, or you could take 14 minus 9, or you could take 19 minus 14. Take any term, subtract the one in front of it. You should get your constant, which is 5 here. Notice that our formula here is actually linear. It's in the form y equals mx plus b. Whenever it's linear, that's going to help us identify it as an arithmetic sequence. And furthermore, when it's linear, our slope is our common difference, d. So if you remember from algebra, our slope is m, which corresponds to 5 here. That's another way to identify the common difference, d. Example 2, find the general term and the 12th term of the arithmetic sequence. So here we're given that it's arithmetic. What are we adding to get to each term? Now notice here we are decreasing in value. So we're actually adding a negative number. We want to make sure we're always considering what we are adding, not what we are subtracting. Because if we answer the question what we're subtracting, it's 2. But we have to use what we are adding. So the common difference d is negative 2. Alright, so we've established that d equals negative 2. Again, if you're not sure how to identify whether it's arithmetic or what the value of d is, you can always take a term and subtract the term in front of it. That's why we call it a common difference. So take 1 minus 3, you get negative 2. Or you take negative 1 minus the term in front of it, 1, you get negative 2, and so on and so forth. Keep in mind that this has to be constant. It has to be the same number each time. All right, so the first part of it is find the general term. The general term really means just find an equation for Tn. And for arithmetic sequences, our formula for T sub n is, for a particular term, is T sub n equals T sub 1 plus n minus 1 times d. Now you don't have to memorize this formula, but you do need to know how to use it. So we're going to keep our T sub n as a variable because we're finding the general term. T1 is our first term, which is 3. N, because it's general, is going to remain n, but d is negative 2. And if we wanted to, we could simplify by distributing. So if we distributed the negative 2, we get minus 2n plus 2, and this works out for Tn to be 5 minus 2n. So this is our general term, meaning that if we plug the value for n, we would get the particular term that corresponds to n. So for example, for n equals 3, if we plugged in 3, we get negative 1, which means our third term should be negative 1, and you can confirm that it is from the sequence. Again, notice that it's in the form y equals mx plus b, and this time your slope m corresponds to the negative 2, right? It's the thing in front of our variable x or n, and that is our value d. Now the next piece of this is to find our 12th term. So to find our 12th term, we are finding t sub 12. And again, anytime you're finding a term, you're using the formula t sub n equals t sub 1 plus n minus 1 times d. Substituting what we know t sub 1 is 3, n is 12, and d is negative 2. And if we evaluate this, we get 3 minus 22, which is negative 19. So our 12th term, if we continued our sequence in this pattern, would be negative 19. Example 3, find the number of terms in the sequence. The number of terms, we're finding our quantifier. How many? So when we're being asked the question, how many, we are being asked to really find n. Again, unless we're finding a sum, we're going to use our formula t sub n equals t sub 1 plus n minus 1 times d. And right now, since we're finding n, we're going to substitute values for every other piece in our equation. So we know t sub 1 is negative 1. Now, we don't know n, but we know the nth term. This is your first term, this is your second term, this is your third term, this is some term, we'll call it our nth term. We know our nth term, so we're going to put that in for 174. And we want to find the n that corresponds to the 174. What place is 174 in our line of numbers here? Now d we can find again by taking any number and subtracting the number in front of it. And we can get d equals 5. So we're going to plug 5 in for d, and now it's a matter of solving our equation. So if we add 1 to both sides, we get 175 equals n minus 1 times 5. The easiest thing to do now is to divide by 5. You could distribute the 5, but it's just a little bit more work. So we get 35 equals n minus 1, which means n equals 36. So there are 36 numbers in this sequence. 174 is the 36th term. It is the value of n that corresponds to 174. Finally, our last example says we have t sub 3 and t sub 15, and we want to find t sub 42. So let's see here. We have 1, 2, our third term is 9.4, and we continue until we get to our 15th term, which is 5, and we continue and we want to find our 42nd term. And if we're finding a term we're going to use our formula for term. Again, we're using as formula when it's arithmetic anytime besides when we're actually finding a sum. So t sub n equals t sub 1 plus n minus 1 times d. And since we're finding t sub 42, we know that n equals 42. But there are two pieces of this formula that are missing. We don't know t1, and we don't know our common difference, d. So let's think about what we are given here. We're given that our third term is 9.4, and our 15th term is 5. So that means if we are at 9.4, we have to add a common difference. 1, 2, 3, keep on counting. How many spaces from 3 to 15? That's 12. So we're going to have to add 12 D's. 12 of these to get to 5. Right? So 9.4, which is where we're starting right now. If we continually add the common difference 12 times, we should get to our term 5. So let's solve this equation for d. 9.4 plus 12d equals 5. 12d equals 5 minus 9.4, which is negative 4.4, and we divide by 12. And d equals negative 11/30. I mean, there's a decimal equivalent, but then we'd have to round, and then we would be off in our answer. So we're going to use the exact value for d, negative 11/30. All right, great. So we know what to plug in for d here. Negative 11/30 corresponds to d. Now we need to find t1. So if we are subtracting 11/30 to go in this direction, we're going to be adding 11/30 to go in the other direction. So you're going to add 11/30 twice to 9.4. So 9.4 plus 2 11/30. And that works out to be, doing this all on my calculator, 152 over 15. Again, this is the most precise answer. If I round it, then it won't make sense. When my rounded answer is not an actual number in the sequence. All right, so we have 152/15 for t1. Now you could find t1 a different way. You could use our formula over again. T sub n equals t1 plus n minus 1 times d, and plug in for everything but t1. And you could use whatever term you want that's given. So if we use 5 for t sub n, we would have to use 15 for n, because 15 is our, 5 is our 15th term. Or you could use 9.4 for t sub n, but then you'd have to use 3 for n. But either way, you could use either formula to find d. Again, let your calculator do the work for you, or t1 rather, not d. And t1 ends up being negative or positive 152/15. All right, so now we want to find our 42nd term. We have enough information in our formula. It's a matter of just letting our calculator do the work. So this is 41 times a negative 11/30. So 152/15 plus 41 times negative 11/30. And you should probably follow along on your own calculator just to make sure that you are getting the same answer as I am. And I'm getting my 42nd term to be negative 4.9. Makes sense it's going to be negative because our values are decreasing here, right? I could change that to a fraction, but it was exactly 4.9, so I'm okay with the decimal as well. So this is standard 7.1. It was the arithmetic part of sequences.